All right, we'll get started. Welcome to Dissecting Kubernetes. I'm Josh Sheppard, Joshua L. Sheppard on Twitter. And today in this session, we're going to talk a little bit about what happens in between when you ask Kubernetes to run your application and then your application actually runs. There's a lot of pieces in play in between, and we will dig into those one at a time. If you were at a session earlier today, it covered what are containers up through how to start using Kubernetes. I'm going to kind of pick up where that left off. If you don't have a lot of experience with containers at all, hopefully that session earlier today will help you out. If you have a lot of experience running Kubernetes in production, you may not get a whole lot out of this session, and I won't be offended if you find a better room to be in. I will also be posting both the slides and the GitHub repo that I use for this so that you can follow along afterwards if you like. So a little bit about me. I currently work at a company called C.H. Robinson. C.H. Robinson is a third-party logistics company that operates worldwide. We work with a lot of carriers and suppliers, connecting them to customers in order to help them get their freight delivered. Through that, we use increasingly more and more data science. This matters to me because I'm the engineering manager of our largest data science team, and this is where Kubernetes enters the picture for me. We use containerized deployments for almost everything that we do, and dealing with the scale that we need to, we are quickly outgrowing a lot of the hand-rolled Docker Compose workflows that we've had before, and that's leading us into Kubernetes. So, with that, a little bit of a read of the room. How many have been working with containers already? Most everybody, but not everybody. Hopefully, I will carry people along. And how many have worked with Kubernetes itself? Good half the room. And with Kubernetes in production, note the distinction between those two. Nights and weekends is fun, but a little bit different than production. So. Getting to that, in a lot of conversations and the session this morning, it kind of covers this gamut. You start at A, you have this desired state, you work with the command line interface, you pass that on to Kubernetes, which is this lovely blue, not quite box, and out comes your running app, if everything goes well. If not, you start wondering what's going on. And if you're like me, you want to dig in, especially when you're thinking about running something in production. Understanding what might be mysterious in the middle is very, very helpful. So for many of us, our journey with Kubernetes starts with Minikube, and everything is going very well. You are working through it, you're feeling aspirational, and you're ready to talk about Kubernetes in production, and you start heading that direction, and then pain. Some may laugh because they've been through this pain, moving into production. Others, like Sarlacc pits, this gap is real. I'm not here trying to sell you Kubernetes. I'm also not trying to steer you away, but you should be aware of what you're getting into if you decide to take on that complexity. As an example, a cautionary tale from a former KubeCon keynote, this one talks about a production outage. No one likes a production outage. In this case, no customers were harmed, but it's an excellent description of what can happen when you upgrade a Kubernetes cluster and the versions don't all match up nicely. In this case, etcd plays a starring role. I won't spoil the punchline, but things can happen even when you know what's going on. This system is very complex. But there are some ways to get your head around it. When I was learning, this guide, while getting a little bit old, is great when it comes to understanding from a developer's point of view, how would I use a container and what are some of the proper nouns in Kubernetes. From a systems administrator's point of view, the Google Kubernetes comic is actually really good. It's a little bit of a sales pitch, tongue-in-cheek as well. But it does cover what are some of the outcomes you're looking for from Kubernetes. What are some of the janitorial work that it saves you from. But for me, I like learning by doing, and I don't like mystery in my production systems. In late 2017, I was learning Kubernetes because the data science team that I was managing was starting to level up from Docker Compose-based workflows into Kubernetes. And I was following Julia Evans, Bork, on Twitter. If you don't already, please consider doing so. She has amazing, amazing content that is both very crunchy and technical, as well as very, very approachable. I happened to see a post that she referenced from Kamal Marhoubi. Kamal Marhoubi had written a post a series of posts really, that talked about building up a Kubernetes cluster one component at a time. The catch being, he did this in 2015. I am in late 2017, and one of the things I was really wondering was, is that still relevant? Is that still how things work? Kubernetes is moving quickly. So I set about actually reproducing that process, and I found that most things worked the same way, but there were enough differences that forced me to learn a little bit more about how the underpinnings of Kubernetes work. And that led to a series of posts because I was going to be explaining this to my team in the office and ultimately to this presentation. So that's the process we're going to go through. We're going to build up a Kubernetes cluster one component at a time. At a high level, Kubernetes looks like this. And on a good day, this is about all you have to care about. You have nodes, you have a control plane, and if you're in a cloud service, that may be somebody else's problem, and a command line interface. If you peel back the covers, you're going to see something that looks somewhat like this. It's more complicated than this, but this is enough to kind of get you started thinking about what you're dealing with. You have nodes that are primarily, but not exclusively, built from Cubelet. Cubelet helps translate from your pod definitions into running containers by integrating with the container runtime. You've got a REST API backed by etcd as a durable key value store that stores the state in your Kubernetes cluster. You have a series of controllers. Scheduler and controller manager are two that we're going to highlight today and dig into because they give you some of those popular abilities and capabilities that Kubernetes provides. And being able to see what life is like without them and with them, to me, was very interesting. But this is a lot. There's a lot to take on all at once. And so what we're going to do, as I promised, is build this up one at a time. We're going to start with Cubelet. So as I mentioned before, Cubelet starts the process for you. Cubelet takes your desired state and works with the container runtime. Often that's Docker, but it doesn't have to be, and turns that into running containers on a particular node. So just to get started with what does that mean, we'll walk that through. Cubelet gets its desired state in one of three ways. First, it can get it from a local manifest directory. This isn't a common practice, but if you need to be running something on a very specific node, it's one technique that can get you by. It can also read its desired state from a URI or a specialized instance of that being the REST API. We will cover that as well. So since we're talking about the kubelet in isolation, we'll focus on that manifest directory. So what I have here is a Vagrant box, an Ubuntu image, and we're going to use this as a starting point. First, we're going to talk through how I set it up, just so you can have a sense of what was involved. Really updating the machine, installing some base software, and then installing Docker. Again, all this code is going to be available on GitHub. Then the second piece of the setup is installing the various pieces of Kubernetes that we're actually going to be digging into here. Setting up the autocomplete, and then downloading a series of configuration files that we will make use of during this process, and set up a couple of empty directories. Not too terribly involved, but it gets us started. We will also be working with an Nginx pod definition. So at this point, we're working with a pod. Cubelet knows how to speak about pods. We have a very, very simple pod. In this case, it's running two containers, Nginx, and in a sidecar pattern, a busy box that acts as a log truncator. Every 10 seconds, it looks at the log file that it sees, and it wipes it out. These are integrated together, looking at the same empty directory, this logs directory that's shared state between the two containers. And Nginx is available on port 80. So what does this do? This gives us a very bare bones example of how a pod ties together multiple containers to give you something. And so it's mainly just to illustrate those 2 points and allow us to talk a little bit about state and a little bit about networking. All right. So just looking to validate that we don't have anything running right now, we're going to go ahead and get started in another instance of that same VM, we're going to start up Cubelet. And in this case, we're going to point it at a local manifest directory like I talked about. Get that running. And we will see that the manifest directory is empty. So right now, our desired state is nothing. We want nothing running. And we can check nothing is running. Hooray, everything's working well. From this point, we want to actually have our pod running. So we're going to copy that Nginx definition into the manifest directory, and now we've got containers running. So that's great. We had a pod definition that included 2 containers, and we see that we've got the busy box running. That's awesome. Nginx, hooray, and a mystery. So think about this. If you are troubleshooting something going wrong in your Kubernetes cluster and something's not right about a particular node, and you dive in and you start taking a look at the container runtime and you see there are containers running that you did not ask for, that may send you down a rabbit hole. In this particular case, this is not what you asked for, but it is what you need. This is the infrastructure container that ties together the pod. We will see in just a minute that it helps you out with networking. It also holds the volume mount that is shared between the other containers. So you did not ask for it, but it happened anyway. We'll come back to this in a little bit. Now, just to talk a little bit further about that networking, we're going to take a look at what we've got for IP addresses. So first, we're going to take a look at the busy box. We're not exposing a port there. No surprise, it doesn't have an IP address. If we come back and grab Nginx, this was terrifying to me at first. What do you mean you don't have an IP address? This is a web server. What good is it going to be? All right, so now let's talk about this infrastructure container. The infrastructure container does, in fact, have an IP address. And if we curl on port 80, we'll see that Nginx is listening. So what is this telling us? So what this is telling us is that the pod, specifically the infrastructure container, has an IP address. And any traffic it gets on port 80 is forwarded to the Nginx container within that pod and serving up the traffic. So basic orchestration, but not quite as I thought about it when I was getting started with Kubernetes. Just learning how the networking and indirection occurs within Kubernetes is a bit of a challenge. This is one example. As you dig in, you'll probably find many more examples to deal with here. So in addition, we'll take a look at the logs. So we're going to take a look at the busy box view of those logs. So there's nothing in that access log right now. And that's not really a surprise. It's truncating it every 10 seconds, and it's probably, I've been yammering a little longer than that already. So we're going to hit that a few different times, and then take a look, and we can see that those 3 requests are referenced here. In a few seconds, we'll check again. We'll see that it's empty. So this very, very minor magic trick just is showing that you can orchestrate state between 2 containers relatively trivially in Kubernetes, and the activities of Cubelet working in conjunction with the container runtime give you that. This is a basic starting point. That's great. You're getting something moving. You have your desired state stored in this manifest directory, and if you wanted nothing to be running again, you can simply remove that file. And we can see that part of this pod is already starting to shut down. Nginx dropped quickly, BusyBox will take a little bit longer, and the infrastructure container will be the last thing to go to shut down. This is important. The infrastructure container's job is basically to never die. It's the first thing that gets spun up and the last thing to spin down. It is really that glue that holds the pod together. That's important, again, just to understand each piece's role in the puzzle. And now they're out. So that's fun. We saw Cubelet in isolation. There are some reasons why you would want to specifically run a particular pod on a particular node. You might imagine that it's got specific hardware that you care about, or maybe this is something that you want to be running on every single node in your cluster. But in a lot of cases, you don't want to SSH into a node to deploy something. I mean, that was the whole point of using Kubernetes in the first place, is you wanted to get your hands away from your production environments. So in order to get to that, we're going to introduce the REST API. And because it's no fun to deal with JSON on the command line, I'm going to add the command line interface as well. JSON is great when you're writing an application. It is no fun to translate back and forth between YAML and JSON and the command line. So also, importantly, while I'm telling you that I'm going to introduce the REST API, we are also implicitly introducing etcd. etcd is the durable key value store that stores the state of your Kubernetes cluster. Generally speaking, this is something that you can take for granted. However, I mentioned earlier in the keynote video where something went wrong. That something was an etcd version. Pay attention. It matters. Everything matters in this. In a lot of cases, it will work out fine. But when it doesn't, you want to have some tools at your disposal to dig in and try and understand what's going on. So what we'll do here is we will shut down our kubelet, and we will start up etcd, the REST API, and then point the kubelet at the REST API to get its desired state, and go through this same exercise. So what we've got here is we're going to manually run etcd as a container in Docker. We're going to run it in detached mode. Many of the pieces of Kubernetes can run as containers and potentially even self-host. It's an interesting thing that you can do. Then we're going to fire up the Kube API server. And what we're doing here is we're telling the Kube API server where can it find etcd. In this case, it's on localhost on the default port. And we're going to give it a range of IP addresses for it to use for the cluster. This is another instance of that, or another session on that same Vagrant box. In this case, we're going to start up Cubelet, and we're going to point it at a config file instead of a manifest directory. This config file tells us where to find the REST API for the cluster so that it can get its desired state from there. So now what we can see with kubectl and get nodes is that we have a kubelet running. It is pulling its name from the host that it's on, and we can see the version of Kubernetes that it's running. And next, we're going to apply that same pod definition through the API. It says that it created a pod. We're going to go take a look and see that it is 0 of 2 ready and pending. Check behind its back, and sure enough, there are no containers running. If we take another look, it's still pending. Now, there's a problem here. We are dealing with a pod definition, and something is missing. So we're going to take a look at what's going on with this pod. So with this describe command, that gives us a few things to pay attention to. We can see that we have our containers, Nginx, and it's running on port 80. We see that it has the volume mount and it's read-write. We've got our busy box with the same definition we had before. And this is particularly helpful, not just the curly braces, but it's actually describing that the state that they are sharing is ephemeral, that it's going to go away when the pod goes away. And when you're triaging in Kubernetes, the events is something that you're really going to want to look for. In this particular case, we have 0 events. There's nothing happening with this pod. That's crazy and frustrating until you realize that we do not have a node specified. So when we were using this same definition in the manifest directory, we were explicitly saying that this is meant for this kubelet. when you are looking at things from the REST API view, you could have many kubelets pointed at it. It's not going to make that decision. Or more importantly, there is a different component that makes that decision for you. However, there are some times, again, like I mentioned with the manifest directory, where you may want to be very specific. I want to run this pod, this workload on exactly this node. So there's a way that we can do that. Oop. Wrong one. So I have another copy of the same pod definition with the only difference is that I have specified the node name. So we will clean up the previous one. And we will apply this new one. This one says that it's created. Same thing that the last one said. We'll double check that it is actually doing something. And it says 2 of 2 running. And if we check behind the back, we can see that we have the containers running, the same 3 that we had last time when we ran it through the manifest directory, as well as the etcd that we were running before. Now, this is a place where I'm going to tell you that Kubernetes sometimes seems to lie to you. I mentioned earlier that you got an extra container that you were not necessarily expecting. It wasn't one that you asked for. If you knew about Kubernetes internals, then okay, fine. Then you probably knew about it. I didn't when I was looking at it. But also, this says 2 of 2. You asked for 2, and it gave you 3. This will mislead you, and is part of the reason why I was mentioning. When something goes wrong and you're looking for extra containers running, that seems like it'd be a good sign that maybe something's not quite right. I'm sure that this is an intentional decision. Why would they tell you that you got 3 things when you only asked for 2? But there is complexity that is being hidden from you. And again, that's fine as long as everything is going well. Something to keep in mind. So in this particular case, we've got that running, and we can shut it down just the same. And we can see that it's in a terminating status. So this will remain there until everything goes away. We can check behind its back to see what Docker says. Docker, as before, Nginx is shut down. BusyBox is taking a little while longer, and the infrastructure container will ultimately be the last one standing. And then we have our awesome mayor etcd. I love the names. All right, so that gets us here. We have the ability to specify a specific node that we want to run our workload on. Again, that's helpful in some cases, but in a lot of situations, you're really wanting Kubernetes to do that work for you. You want it to make that decision. You just want to say, run my stuff, and Kubernetes should just handle it. In order to figure out what piece actually does that, we're going to introduce our first controller. The scheduler actually makes that decision for you. It considers a lot of options, how many pods are running, what are the resources that the pod needs, what resources are available. This helps you get that density of use of your nodes that you're hoping that Kubernetes will give you. It also saves you from having to make the tedious decision of where exactly should I place my workload. We will go through this again real quick just to show you what that looks like if you have that additional piece in place. So this is another session on that same Vagrant box. And again, just like the kubelet, we're going to run the scheduler pointed at the kubeconfig file. This kubeconfig file tells us where to find our REST API. And we'll get that rolling. I'm going to validate that I've actually cleaned up. See that there's nothing there. We're going to go back and apply that original pod definition. So this is the one that does not specify the node name, just to show you that it does in fact do what I said. So 2 of 2 running. It has scheduled this onto a node, And again, we can check behind its back and see that our containers are running just like before. So the scheduler is very, very quickly picking it up and making the decision. So what does that look like? You are telling the REST API, I desire to have this pod running in my cluster somewhere. The scheduler says, hey, there's a pod that has not yet been scheduled to a node. I can fix that. I happen to know this Ubuntu Bionic node can take this workload. The Cubelet is monitoring the REST API as well. And it sees that there's work to do. There's a desired state that is not matching the current state on that node. It pulls down that definition, works with the container runtime, and fires up those containers for you. Each of these pieces is handling a slice of that activity. That is another important concept to keep in mind. We will cover a few more of these, but that pattern, that controller pattern where something is observing the desired state and reconciling that with the current state is really, really common in Kubernetes, especially in the control plane. You can provide your own scheduler. You don't have to use this one. If you have some very specific needs, you could do that. If you're wanting to customize your Kubernetes cluster, you may add some custom components. You would do that probably by adding a resource definition and implementing your own controller. So, how many of you noticed what version of Kubernetes I was running? Got my plant and one more. Excellent. So, for those that didn't, we'll pull this up. Version 1.9.11. The vintage on 1.9 is something like 18 months ago, maybe longer. Why on earth would I be demoing in 2019 something that came out in early 2018? And the answer is the next version of Kubernetes broke this demo. Just to prove that, I will shut down what we've got going on here and show you. And I'm going to show you because Kubernetes upgrades, even if they are minor versions, are very impactful and sometimes break your world. So just give me a second here. Hopefully this is the longest I make you wait. So at this point, we are in a similar Vagrant box. And what we will do is we will go through the setup just like we did before. So we're going to get etcd running, just like we did before. We will start up the API server, just like we did before. We will run Cubelet, just like we did before. We will run the scheduler, just like we did before. And we will see that there's nothing running right now, and see that we are running version 1.16.1, which is, for last I checked last night, was still the most current version of Kubernetes available. And we will apply that original pod definition. So in version 1.9.11, this worked fine. And after a brief pause, we get an error that cost me a weekend. This error is a little cryptic, or at least it was for me. It's a little hard to Google for because no one sets up a cluster one component at a time. And if you don't know, if you haven't really been digging into security, you may not be super familiar with service accounts, and even if you are, default/default may not mean anything to you. In this particular case, I will spare you the long piece. Default is the namespace, and default is the service account within that. And we need another component in Kubernetes to set this up. So that is the controller manager. The controller manager includes many controllers bundled up together. I'm not entirely sure why, but one of those is the service account controller. The service account controller needs to, as of version 1.10, establish the default service account for you, which is why my demo, in the order that I gave it, was no longer valid. But it's not that simple. You can't just, oh, well, I'll just run the controller manager ahead of time and I just won't tell anybody about it. That's not going to work either. You have to add a PEM file. You need to give it credentials so that it can establish these accounts. So let's look at what it takes to get that done. So for that, we'll take another look at what the setup was for this one that was slightly different. In this particular case, we added in GCC, we downloaded Go, we added 2 more Cloudflare utilities that we can then use to build up our certificates. And then in the second setup file, in addition to downloading the newest version of Kubernetes, we also added this additional script, generate service account PEMs, and I'll show you what that does here in a second. So this is heavily cribbed from Kelsey Hightower's excellent Kubernetes the Hard Way, in particular where they're provisioning certificate authorities. All of this script is everything that is necessary just to get this one file. Everything broke because I didn't have the controller manager running and it didn't have access to this one PEM file. For our purposes, I already have that available. And so what we can do is we can get the controller manager running in yet another session on this machine. And we're going to start it up much like we did with the scheduler and the kubelet. We're going to point it at the kubeconfig that tells us where the REST API is, and we're going to provide the service account key PEM file so that it can act as the private key to create the certificates we need. We get that running. And now, if we apply that same file that was not working before, we should see that pod was created and 2 of 2 running. So this is an example where updates change the behavior in Kubernetes. Could be a default. In this case, this is a good default. You want your cluster to be more secure by default. This seems like it will help you from hurting yourself. It did not make my demo any easier. It dramatically complicates things. And I would say that to say Kubernetes is complicated. You really need to think about, do you need that complexity in your setup? There are a lot of things that can go wrong. There are a lot of powers that Kubernetes brings to the table for you, but they come at a cost. And that cost will require a lot of learning from you and your team. So we've talked about the service account, but the controller manager does way more than that. In particular, we're talking about deployments and replica sets. If you were in the session earlier today, there was a mention that you shouldn't use naked pods. I agree with that, except that if all you have is a kubelet, that's really all you've got. You need to add the controller manager to be able to have anything that knows how to talk about a deployment or a replica set. So now that we have the controller manager running, we can introduce those. So instead of looking at a pod definition, we'll look at a deployment definition. It's not particularly interesting, and explaining the YAML is not really the primary portion of this session. However, we can see that we have an incredibly creatively named deployment. We have our 2 containers from before, Nginx and BusyBox, exactly specified as they were in the previous portions of the demo. and interestingly, this line. So this line, as Scott talked about in the earlier session today, talks about the replica set. In this case, we want 3 copies of whatever we find in the spec running at all times. And the replica set will take care of that. And wrapped around the replica set is a deployment, which allows us to have additional capabilities in regards to rolling deploys or other things. So how do we make use of this? We can first validate what I've got running. We're going to shut those down just to avoid confusion. Here's another place. If you remember before, every time I deleted a pod, it was instantaneous. It took a while for everything to get shut down, but the command returned immediately. It doesn't here. Another feature of the upgrade. Now, deleting is a blocking command for pods. This will not return until that busy box and the infrastructure container shut down. If you had a script that depended on an immediate return here, you may have challenges in your system because you upgraded. I doubt anywhere that this is recorded in the release notes. I couldn't find it. If you can, and you want to send me a link to it, that would be wonderful just to prove me wrong. But there will be things that change that never made it into any documentation that you will see. The behavior changed sometimes in a meaningful way that can trip you up. Anytime I see a pause like that, it makes me feel like I broke something. Something went wrong. In this case, no, it's just trying to be helpful. It's not going to tell you it's done until it's done. I actually kind of like that behavior, but it was surprising. All right. Now, we can do the same thing with our deployment that we did with the other piece. We're going to deploy this, learn how to type. So we're going to use get all, and I use get all here because it can show me the deployment that we asked for, the replica set that is created, and the 3 pods that came out of this. So what happened here? We asked for a deployment. The deployment controller sorted that out for us. That in turn said, hey, we need a replica set. The replication controller handled that, created the replica set. The replica set said, hey, we need to have 3 versions of, or 3 copies of this pod running at all times. It created 3 desired pods as part of the desired state in the API. And the scheduler said, I know what to do with that. And it put them on the node. It assigned them to a kubelet that it needed to run. Cubelet then was watching, picked that up, and started getting that running. So that's great. We've got 3 running. We've spent probably more resources than we really needed to. This application really doesn't need all of that. So we're going to scale that back. This is where we see that with a replica set, this gives us that scaling capability with a single command from Kubernetes. That's handy. Get all, and we see that we've got 2 pods that are terminating and 1 that's still running. So this is helpful. We can see what happened. We can scale quickly. The problem being my boss just walked up to me and said, we have a demo and this thing needs to have all the scaling. We're going to go back, quickly bump this up to 5. And we will see a lot of stuff going on here. First thing, the 2 pods that were terminating are still terminating. They were not resuscitated. This is important. Once a pod starts to terminate, it's out. The reason for that is that once a pod starts to terminate, it may be in an unknown state, and that's not helpful. The replica set instead creates 4 more, the 1 that was already running, plus the 4 more to get the 5 that were desired. And those are in process here. And we should see that they're all running. Every Kubernetes has reconciled what we want to be true, our desired state, with the reality in this cluster. And just like with our pods, we can clean this up just as easily. Note, this returned instantaneously. If we get all, yeah, the deployment shut down, but those pods, they're still terminating. Again, there are things that are going on, and sometimes you can tell a story, you can think about like, oh, well, it was returning. I really only asked about the deployment, so maybe that's okay. The pods are this extra thing. But if you were learning about how pods return, you might be a little surprised that this isn't actually behaving maybe consistently to how you're thinking about it here. It happens. There are things that change. Sometimes that change takes a while to ripple through the Kubernetes ecosystem. Importantly, thinking about how Kubernetes upgrades affect each of these components and your deployments is important. You want to know that what you deployed yesterday, you can still deploy again tomorrow. And to that end, make sure you're testing these new versions. Don't just upgrade and hope it's going to be fine. I have been burned by that a number of times. I've highlighted a few of those just in this. The keynote that I referenced earlier was a great example where a team that really knew what they were doing still got burned by version dependencies. So again, we've talked about each of these components. You have nodes, primarily but not exclusively formed of a kubelet. You have a REST API backed by etcd, storing the state, etcd being a durable key value store. You've got a command line interface that makes it a lot easier to interact and translate between YAML files and the JSON that the REST API speaks. Interestingly, you can write applications that speak directly to the REST API in JSON. There's nothing saying that you can't. It's actually a really great way to interact with your Kubernetes cluster. And you have controllers. We talked about the scheduler and the controller manager as examples. You have these control loops, these very tight control loops that function by observing the desired state and reconciling that with the actual state in your cluster. From that, we originally were starting with a model that looks like this. I've got my desired state as YAML file, I've got my command line interface, we've got our wonderful Kubernetes in the middle, and my app starts running. Hopefully you can see a little bit better about how to reason about, how to think about what's going on in that blue heptagon in the middle. If you liked this session, but you want more, I highly, highly recommend Kubernetes Deconstructed by Carson Anderson. This one, where mine was a high-level pass that kept some things out for speed of the session. Carson goes really, really, really fast and really low level. Covers a lot of security and networking. It is fantastic, and it's great that it's a recorded video because then you can pause it and rewind it. There's a lot of content in there, but it is great. So this is a link to the GitHub where I have all the source material for this. It also has links to each of the videos and resources that I referenced here, so you don't have to try and copy them out of pictures of a slide. And I will tweet out both the link to the slide deck and the GitHub repo later on today. And I have plenty of time for questions. Yes?
Is there a way to auto-scale the replicas?
Yes, so auto-scaling is something that you can do with the pieces that I was working with. That doesn't really get into it. But is there a session later this week? All right, there will be a session later this week that will kind of dig in a little bit more. Highly recommend it. So in some cases, you have to kind of build that up yourself is part of it. Depends on where you're hosted also. Other questions? If there are no more questions, thank you very much for your time, and I hope you have an excellent NDC Sydney. If you are a fan of funky looking stickers, I also have some, and you're welcome to have them.